I'm loading slowly. Very, very, very slowly. Please place your quarters into the slot so I can load more quickly. More quarters, super chat, pay, speed up my buffering. All right. I could have spent more time working on that and rehearsing that. But here I am. It is me, Dan Schiffman, on a special Thursday coding train, hopefully coming at you at regular, normal buffering speed. Let me just switch back to my laptop view. It's still there. Maybe as a coding challenge, we should make buffering animations today. Oh, and then the camera went off, of course. All right, so much for my shtick. I really, I'm getting high ratings. I'm getting high ratings for my ridiculously bad goofing around. All right, let me see here. Now, how do I make that go away? It went away. And here we are. Hello and welcome to a special Friday edition of every 2 or 3 minutes I'm going to come back to buffering. I'm buffering. I'm buffering. I'm buffering. I'm buffering. I'm buffering. How high would this thing go? Whoa, look at this. Whoa. Oh my goodness. Ah. What you will be watching today is a person, a human being on the internet using a standing desk that goes down and up and down and up until you put more money, feed it into the machine. Send me your Bitcoin, your cryptocurrency of choice, and then I will come to you. Uh-oh, somebody actually gave me a super chat donation. That was a joke. I'm doing fine. Everything's fine. I'm okay. All right. Here we go. Wait. Hello and welcome to a special Thursday Coding Train episode with me, your host, Dan Schiffman. Coding Train, as you know, is brought to you by water. And I don't want to buzz market this. Because of the buffering, I've had to use a plastic bottle. Can you see what's going on in the world now? So, I'm here a couple extra times this week. I was here on Tuesday and I'm here today because I'm trying to make up for some missed weeks in November and December. I will also be back tomorrow morning if all goes according to plan and my broadcasting setup still works. And I'm going to be today continuing the WebGL 3D and p5.js tutorials that I was doing earlier this week on Tuesday. So that's what I'm going to get started on very, very soon. And I'm looking at the chat, and some people are asking some questions. Where can I buy a shirt of the channel? Oh, are you looking for a last-minute holiday gift? Oh, how do I get to the buffering? Never mind, forget about the buffering. If you feel like getting some Coding Train merchandise, the URL for that is codingtrain.storeenvy.com. You can also go to amazon.com/shop the Coding Train and find all sorts of book recommendations and things. You can get your very own copy of the Coding Train, brought to you by 1,000,000 Random Digits with 100,000 Normal Deviates. It's my favorite book. It's the book that I read to my children at night before they go to sleep. And in fact, it is the book that I will read some of which to you right now. Are my random numbers coming at you in regular internet speed or slower? 49,847. 16,212. 69,279. 87,888. I'm melting. As always, I always forget the this dot, this dot, this dot, this dot. All right, let's actually do some coding and stuff now. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot. Okay, I'm warmed up now. So let me figure out where we were last time. I'm not organized, so I got to get myself organized here. Whew, whew, it's getting hot in here. Let's see. So first thing I want to do is open up Terminal. And second thing I want to do is go to my Finder, maybe the desktop, WebGL, p5 WebGL. So this is where I was working on some WebGL stuff. So let me go there. So I need to go to the desktop. Uh-oh. This computer just went away. Come back. WebGL. And let's run a server. Let's see where we last left off. RS. We had the spinning, normal, torus. So what I'm going to do first, but there was a lot of debugging and figuring stuff out, so I'm going to see if from that session I can make a tutorial that kind of makes some sense and covers the different pieces. I corrected some things in the, the things that I want to have open are the reference. I know that Simon has made a wonderful p5 WebGL cheat sheet, I might call this, which I can which allows me to quickly look at all the different kinds of light and materials. Great ambient, material, normal, excellent, excellent, excellent. Okay, and then now here's the tricky thing. You might recall, whoops, that last time, on last coding train, I had this whole WebGL diagram all written over here on this whiteboard right behind me. It's been erased. So I think I might want to try to recreate that. Does anybody have a screenshot for me that you can share, probably in the Patreon Slack group? Oh, I should mention, just as a matter of update, Patreon did make an announcement this week that they are not going to implement the fee changes that just about everyone universally did not like, creators and patrons included. So if you did cancel your pledge because of the Patreon fees changes, that's totally understandable. You're not at all required to repledge, but if you wanted to repledge, you can. And just as a reminder, pledging to Patreon is, with that, you get an invite to the Slack group and some other various things at different levels. Okay, so everyone wants me to do shaders. Shaders is not going to happen today, but it is on my list of things to do at some point eventually. So, okay, I'm waiting for my someone to give me a screenshot of that diagram. I guess I could look it up myself. I could not be so lazy. Oh, somebody, I got it already. Thank you, Matthew in the Slack channel. So let's see. I'm going to attempt to recreate this as much as possible. This is kind of silly that I'm doing this. Oh, and my eyesight is just not good enough. So I wrote WebGL here. And I had a list, 3D geometry, camera, all right. 3D geometry, camera, material, texture, lights. These are now in a different, these are in a different order. That's fine. Where's my eraser? I'll just use this. Ah! Woo! Yikes. Texture, material, lights. What else do I got over here? Normal I talked about, but I talked about that later. And then I just had over here, create canvas. And I just said something like blank, comma, WebGL with something like this. Approximately, just to kind of make it look vaguely similar to what it was before. I had something like this and said that was 3D. What else is there? Hardware accelerated. Ah, right. I was talking about OpenGL and hardware accelerated. And that's good enough, I think. Okay. Whoops, where am I? Over here now. Okay, so thank you for that, Matthew. And okay, now, so let me think here. Now, here's the other question. This code, oh, now I need to open up the code. This code is a mess of things. So where did I leave it? What was at the end of, I think I might just have to look at my live stream from last time. So if I look for, hello, computer. This is the previous live stream from a couple days ago. And at some point, I start talking about material.
The browser has to support WebGL. The browser doesn't support WebGL, none of this will work. All right. Let's see, what am I going to get to next?
I'm watching myself. Sorry, you guys can't hear this.
Material and texture.
Okay. So this looks like, I think, where the code was where it left off. So it was just a torus rotating with no light. Maybe was the background there just black?
Tube radius is bigger than the radius. Interesting. Okay, how are we doing here?
Sorry, I went back too far.
Normals. Well, you guys and all your 3D stuff.
Wait, this is me in 2x speed. Yeah, okay, okay, yep, there we go. Sorry, I just needed to see that. Okay, now let me come back to here. Huh? Save. Oh, it's caching. Or not? Does it? Am I not looking at the right sketch? No, I am. Oh, there we go. What was it, like much thinner or something? There we go. Use the arrow keys to skip forward and backward 5 seconds. That's great. I didn't know that. Yes, Topher asks, so he's going to redo the materials and light stuff. Yeah, so I apologize for this, but I did look it over, and I think this is one of those cases where I was like swapping out the P5 library, and then I made the, it's not worth, it's not worth having somebody have to watch a like hour-long debugging session for me if they just want to see a tutorial about material and lights. And B, if Mathieu and I were to edit that hour thing down, it's just going to be so jumbled and messy that it's actually, it's better use of time to just spend the 20 minutes to do the tutorial again. The thing that's a kind of an issue is I'm kind of, my brain is out of sorts. I don't really, when I do these sessions, I have a very clear picture of where I last left off and what I was saying, and I actually kind of completely forgotten. But I think if I start from here and just open with what I'm going to do are materials and lights. And so what I need is, what I also need is the P5 WebGL tutorial. This is a very, getting started. Definitely want this, and I want to have lights and materials. Okay. So I want to take a little, okay, I'm going to leave it as is. Okay. The other thing that I would like to do is, remember we found some really key bugs, and I was kind of going back to old versions of P5 and new versions to like fix those bugs. So let me, let's take a minute, if you guys could help me remember this. Oops. Let me first look and see, did anyone post any of these issues? So this is 2 days ago. I wonder if this is somebody who posted this issue because I'm planning to do a video about this. Oh, non-square. Okay, so this is interesting. We're going to look at this when we get to textures. There's also this from 9 days ago. So this is way before. So what I want to look at is lights WebGL. Let's look for that. This is a very old issue. So I think this one has been, so I think one of the things I want to do is file some issues. So, I'm going to keep track of this stuff also. So, what were the issues? Where can I keep track of this stuff? I'm going to make a, so I'm going to file these issues later in the stream so that everyone doesn't have to sit through it right now if you really just want to look at the tutorial material. But like, I really should have kept these notes before. And what version are we on? 16. Point light and directional light calls overwrite previous lights. There is only one, rather. Okay, so that's one thing. That's what I remember. Were there some other things? There was something with, I think it was there. Yeah, I'm looking to see in the chat. Yeah, you know what's something I'm kind of interested in? I was actually curious to redo the bees and bombs cube wave in processing in P3D mode, just to kind of compare and see what it looks like there. If there's time today and people are interested in that, I would love to do that. Same with directional lights, yeah. All right, so hopefully these will come up again. So right now, I'm using the old version. Currently using the old version, which I don't want to use, but that will work. What I do want to see is, does the normal material, yeah, okay, that's fine. So I'm going to, for the purpose of this tutorial, use the older version of P5. I think I can get a little more space here. And here we go. All right. Neural networks and machine learning coming in 2018 in January. That's when I'm going to get started. This week and next week is really about me trying to wrap up some stuff, although I do hope to do some tutorials around a word to vec and maybe even some clustering, some machine learning topics that without neural networks before the end of next week. All right, so let me get started here. In the newer one, the Y is not flipped. Thank you, Simon, for mentioning that. So in other words, for the lights, or for the, oh, the lights aren't flipped for the, is that just for the lights? So check Y, Y direction, 0.5.16 versus 0.5.7. So let me just check really quickly this. So in other words, if I say translate, if I say translate 0, 50 with Y being flipped, it went down. It went down. Okay, but in the new version of P5, whoa, and I get the wireframe. So that's right. So Y isn't flipped. It goes down in both versions. But do the lights do something different? All right, let's just humor me for a second here. Point light. What do I use for a point light? First I do the color, and then the location. 0, 50, 0. Oh, I have the fill on. Turn that off. So this is very hard for me to see where the light is because it's not a sphere. So the light is, sorry everybody, but this is sort of important for me to figure out. Okay, so negative 200, the light is coming from above. The light is coming from above, so that's working correctly. And that's in the new version. In the old version, it's the lights. So as long as I don't move the Y location of the lights around, I can have multiple point lights. If I have one point light, you know what I'm going to do? Here's what I'm going to do. I'm going to use the current version of P5. And then at any point in this tutorial, if I want to show two lights, I'm going to, switch it, and the switching will get edited out to the old version of the library. And so any bugs that are in the old version of the library, I don't care about those. The light being positioned in the correct place in the new version is correct. So I need to go back to take out this point light, take out this translate, put this back to torus, it's 100, and put this in fill 255. Oops, and 0, 0, 255. There we go. Okay. So here we go. So I am going to get started now. Thanks everybody for your patience as I try to sort this out. This has been really difficult to do these tutorials, but I feel like it's important to, if WebGL is to be a part of P5 and all of this work that went into it over the summer to get some more people trying it and helping with fixing some of these bugs and finding some of these bugs, that's only a good thing, I hope. At least that's my desire. My intentions are in the right place. I'm sure I screw everything up though most of the time. All right. Okay, this is yet another video about 3D, 3D, or WebGL rendering mode in p5.js. This is where I last left off, essentially in the previous video, where I spent most of my time simply looking at 3D geometry. So what does it mean to suddenly use translate with a z-axis? What does it mean to rotate with an x-axis, a y-axis, or a z-axis? And what kinds of 3D primitives are there? Cone, box, torus, all of these things. So, but what I want to explore in this video is material and lights. What are these things? So material describes the sort of skin of the 3D object. How does that skin behave when it receives, when light shines on it? Right? In a 2D world, there's no such thing as lights. We are just setting colors precisely. We're saying, draw this rectangle with this color. But in the 3D renderer, we have the option of saying, hey, draw this shape with this material and then shine this light on it. And depending on what material we use, depending on what light we use and where we place that light, we can create different looks and feels. We've relinquished a lot of control to the sort of pixel level determination of what we're drawing, but we're now gaining this illusion of shadowing and lights in three-dimensional perspective. So let's go take a look at that. Now, first of all, there is actually already a material present in this particular example. I would love to make a list of those things and write them on the board, but I'm actually just going to go here. I'll actually show you. This is a quick cheat sheet that Coding Train viewer Simon made. So I'm going to go under material here. So you can see these are some different kinds of material that we're going to explore. And at some point I want to get into texture and maybe shaders as well. So, but I'm going to go back to this getting started tutorial, and you can see at one point, actually, or in a lot of 3D environments, there's something called a basic material. A basic material is a material that fills the shape's surface with color which does not respond to light. And that's actually what fill is doing. So in this particular example, this fill function is applying a basic material. And if I were to add a little bit of red to that, we would see suddenly, it's a little bit, I better add some more red. That barely made a change. There we go. We can see that I'm altering the color of this beautiful spinning torus. Okay. So step one. Now, what if we wanted to add some lights to this scene? So the first kind of light, let's go with this. The first kind of light that we could add, I don't know why I'm doing lights first. I should probably just keep talking about materials. Let's keep talking about materials. Okay, let's add a material. Now, one of the materials that we can choose to add is something called a normal material. You might be asking, what is a normal? Let's talk about a normal for a second. I just feel like, all right. I'm not reading the YouTube chat until you all clean up your act. All right. I'm taking a little pause here for a second. All right. So let's first experiment with material. So I'm actually going to take out the fill. And I'm going to add something called a normal material. Normal material. And let's see what happens. Look what I have now. I have this beautiful rainbow-colored torus. In fact, what the normal material does is assigns to every vertex, which has an x, y, z position, it assigns a color. The x position of the vertex relative to the object center gives it its red value, its y position, its green value, and its z position, its blue value. And this is actually really, this normal material is just for the purpose of debugging. So if you haven't figured out what colors you want things to be or what textures, you just want to see your 3D shapes and be able to see them as 3D, just adding a normal material is useful. Now, the reason, time out for a second. So I was gonna use this as an opportunity to segue into talking about what a normal is, which is kind of relevant because the normal is the vector that is perpendicular to the plane, and and that's kind of how it determines how the light reflects off of it. But is normal material called normal material actually because of this normal vector? Or is it just called normal material because it's like the sort of more, the word normal, it's normal. Normal. Boy, I'm doing so much better than last time, aren't I? Normal material. It is a representation of the normals. Right, okay, so that's good. All right, so I'm gonna keep going. And I don't think I talked about this. See, I'm just having trouble remembering what I talked about in the previous video, but okay. Talking about the normal material is a nice excuse for us to just remind ourselves that this shape, right, isn't actually a smooth shape. If I turn the stroke back on and turn the fill back on, whoops. Oh, it says no stroke there. We can see this is actually just a tiled collection of polygons. And what the normal is, the normal vector for any given polygon, like say this triangle here, is a vector that points outward from the polygon, is perpendicular to the plane. And that vector, that normal vector, is associated with how the light reflects off of that plane. So normal material is using the normal vector to assign an RGB value. Okay, but really in this case, it's just something that you would use for debugging or as kind of like a default material. Or if you just like rainbows and you want everything to be rainbow colored, hey, why not use the normal material? So let's go back here. Okay, so now we're back. Aha, okay, so now let's start thinking about some actual materials that we might want to use. For example, an ambient material. So I'm going to call this an ambient material. Whoops. I'm going to get rid of the fill, and I shouldn't have had the fill there. Normal, you can only have one material. So fill, you can think of it as basic material. So normal material just overwrote that. I'm going to say ambient material, and I'm going to say 0, 0, 255. Let's see what's going on now. Now look at this. Why is that not blue? I said ambient material, but it's not blue. Why? An ambient material, unlike a basic material or fill, which just gives the shape that color no matter what the lights are, an ambient material is a material that reflects light. So only if there is light of a particular color will it reflect that. So for example, I could add some ambient light. I'm going to put the order doesn't matter. I mean, the order does matter, but it doesn't matter. I'm going to say ambient light, and I'm going to give a red light. And you might ask the question now, so if I have an ambient material of blue and an ambient light of red, shouldn't I see purple? I still only see black. And because the material can only reflect the color blue, and I'm only shining the color red on it. So this is something you really have to think about. You could try to imagine like a reflective surface that only reflects one kind of color, and you have the flashlight of a certain color. That's the kind of thing you need to be thinking about. So what I might do here is just make the ambient color white, the ambient light white, and you can see now I've got the blue, and I forgot to say no stroke. So we can see now this looks just like the fill. So an ambient material of blue with a blue light, it looks exactly the same. Now here's something interesting though. What if I were to, there's a couple things. One is I could actually just make the material white and then shine a blue light on it. Exactly the same result. So that's important to realize. That's exactly the same result. Obviously, it's going to be different if there's lots of shapes with different material colors. But what I want to point out here, which I think is important, is let me just change this torus for a second to a sphere. A beautiful, round, three-dimensional sphere. Whoa, way too big. 100. That looks to me just like an ellipse. if you look closely, you can kind of see there's some kind of spinning or rotating here. But an ambient light, the thing to realize about ambient light is an ambient light is a light that shines from everywhere in all directions. So it's kind of like a magical light. It's not coming from a particular source. It's not shining in a particular direction. And so in this case, I don't really see the three-dimensional quality of the sphere because there's no shadowing. So in this case, what I want to look at is what if I use something called a point light. So we're going to look at ambient light, point light, and directional light. A point light is a light that I could place, think of a light bulb that I can place into the scene. It shines in all directions from a particular location. So what if I wanted to put a point light over here? Let's do that. So I'm going to say point light, and I still give it the color, 00255 blue, but now it's not ambient. It needs to give it a location. So I'm going to say 0, -200, 0. So I want it just to be a point light that's positioned over here at the edge, right where my finger is, right there. Okay, here we go. Ready? Whoa! Oh, I'm sorry. I put it at the Y location. So it actually worked. I put it above. I just got the wrong spot. So it's important to look at the documentation. If we look at Simon's cheat sheet here, point light RGB, RGB XYZ. So the X position is this one. And I'm going to make that 200. Oh, -200. I wanted to put it over there. Oops. And go back to my sketch. And there we go. We can see it's to the left. I could actually give it, you know, I could say mouse X -200 or mouse Y -200. And now you can see I have this point light that I can move around. And I could put 2 point lights in the scene. Timeout, edit. Oops. And say add 1 point light, -200, 0, and another point light at 200, 0, and make that one red. And we could see, whoops, well, whatever, it doesn't matter. The point is I'm putting them in different locations. But you can see now I have a point light shining from over here that's red and a point light shining from over here that's blue. So point lights are things you can position, move, and give them different colors. Now, let's think about material for a second. So this is ambient material. Ambient material is a material that reflects it reflects light. There is another kind of material that also reflects light, but reflects it in a slightly different way if you want a different look, and that's called specular material. And specular material is a material that's shinier, more metallic, and kind of, you know, a billiard ball or water or metal or something, you can get a slightly different look. So let's just look at that. I'm going to say a specular material, and I'm going to leave the color white, meaning the material is white, so it's just reflecting whatever light is there. And we can see, look at this, you can kind of see this like shiny quality to this. So I might want to do some more experimentation of sphere, like the detail of the sphere and where it is and how bright the light is and different lights. You can see that the specular material is quite kind of dark, but you could imagine if maybe this were a much smaller sphere. I don't know, that didn't really change anything, never mind. I'll leave it to you to experiment with different materials and different colored lights and different shapes. Okay, so I'm going to go back to ambient material and point light. Now, I want to look at I think the last thing we've got to look at here is directional light. So what is a directional light? Directional light is an interesting thing. It's a light that has a direction, but no position, meaning it's kind of infinitely far away. So if you can imagine, I'm in the 3D scene right here, and I'm going to say the sun is over there, right? The sun is not infinitely far away, but it's so far that you can kind of imagine it. So I'm pointing in the direction of where the light's coming from. So this is different than what you might think of as a spotlight or a flashlight, which would be like the combination of a point light and a directional light, a light at a certain point that points in a certain direction. That, as far as I know, is not implemented yet in p5 WebGL renderer, but you can have a point light and or a directional light. So let's make a directional light happen. And edit point here while I go back to the p5 library. So instead of having a blue, and what's yellow? Red and green, right? Let's try to make the sun. Instead of having a blue point light, I'm going to change this to directional light. And now this vector over here describes the direction of the light. So if I want to have the light coming from over there, like coming from the right, I want to say the vector points 1 in the x direction. So I'm going to say 1, 0, 0. And let's go refresh this. And you can see there's the yellow light coming from the right, this direction. Okay? And if I were to say -1 there, it's coming from the other side. If I were to say it's coming from the front, like as if your eyes are the light, you can see that. My eyes are shining light directly into the scene. So you can see how powerful this directional light can be. So here's the thing. One thing we could do now is we could have a directional light point into the scene based on the mouse. So for example, I could make a variable that is the mouse x minus the center of the window and mouse y minus the center of the window. Now something weird is going to happen here. And I should probably put this back to the torus because I think it's going to be easier to see with the torus. And so I'm going to say, and now I want the directional light to be dx and dy. Let's see what happens. Now look at this. I'm getting this kind of glitchy effect. The reason this is happening is the vector is, so ideally, if you want the effect that I want, at least here, the vector, that thing that's pointing, needs to be of length 1. And I didn't have to worry about that when I said 1, 0, 0 or 0, 1, 0, because it was by definition length 1. Because it's not that it adds up to 1, but it's like the length, its actual length is 1. So in this case, the vector is like, if I could kind of get the mouse really close to the center, and you could sort of see how I can get some of that shading back, but the light gets stronger. So this is something you might be able to use to your advantage, but ultimately I want to normalize the length of that vector. And there's a nice way that I can do that, because what I could do is I could say let v, I can make a vector object, make a vector which has an x component, a y component, and a z component, which I'm leaving at 0 for right now. And I could just pass that vector in as the last argument. So the directional light has a color and a vector. Same result here. But now I could say v.normalize. And what the normalize function does is shrinks the vector to length 1. And you can see now as I move the mouse around, I'm changing the direction that the light is shining. And maybe I could do something like, I could do something like divide it by 100. And so you can see I can make the light kind of brighter based on like how far away the mouse is. So I just want to be within a pretty reasonable range. Once I get such a high range, it's very, very glitchy. So the strength of that light, it appears, also is tied to the length of that vector. Okay, so let's take a look here. I think we've talked about normal material. Normal material, so basic material, by the way, is fill. And just so you notice here, if I go back, this is actually important to say, if I go back and say fill 0, 0, 255, comment out the ambient material, and I still have the lights and everything, you can see that light is not affecting this. So an object that doesn't interact with any of the lights in the scene, you can use fill. It's pretty rare that you would probably want that to happen, but just to note, if you're wondering like, why is nothing responding to my light if you're using fill? So fill, like a basic material. Ambient material is a material that reflects light. Specular material is a material that reflects light, albeit in a slightly different, shinier, perhaps, way. And then the three kind of lights are ambient light, a just general wash of light from everywhere in every direction. Point light, which is a light where you give a position, and a color. So it emanates in all directions, but from one position. And directional light is a light that's coming from a given direction, essentially infinitely far away. Maybe like, depending on the length of the vector, it's closer and closer or brighter and brighter. Okay, so that, I think, concludes, So that, I think, So that, I think, concludes everything, right? Normal, ambient, specular material, and then ambient light, directional light, point light. Okay, so if you have some questions, write about them in the comments. I'm sure I missed lots of important 3D stuff, but I will be in the next video now getting to looking at texture. And then at some point I will talk about camera and perspective. Okay, see you there. All right, how did I do there? That was better. Okay. Isn't sunlight? Oh yeah, I should say that. Sorry, I'm in the wrong camera. Sun isn't yellow. Oh, do I need to issue a correction? Am I going to be flooded with comments about the sun is white light? Hold on. Let's just. Mathieu, you probably don't want to include this, but I'm going to. You can edit this in if you want. I should point out, as mentioned in the chat, that the sun isn't actually yellow light. I'm just thinking of how my first grader loves to draw the sun and uses a yellow crayon. The sun, of course, is white light, and it's probably even more complex scientifically than that, but I'm just using yellow to think about the sun in some arbitrary way. Apologies for that. Please don't flood the comments. Okay. So that's better, even though the sun itself is orange. All right. Simon's making the point that it would be useful to show what happens if you put point light and directional light and an ambient light. I'm going to leave that as an exercise for people to mix them. I should probably say that explicitly, although it is important to mention, perhaps, maybe, all right, maybe Mathieu wants to edit this stuff in, so let's try. A couple other things that were pointed out by the chat before I go. If I were to add an ambient light here, and let me make that ambient light blue, let's just see what happens. So you can see, interestingly enough, the ambient light and the directional light are interacting with each other. And everything is blue everywhere, but the red and green that's coming in through the directional light mix with that blue and end up making white light. Now, of course, if this were to be just red, the directional light, you can see that directional light is now mixing with the ambient light and making pink. So this I really want to leave to you as an exercise, mixing point lights, directional lights, ambient lights, all of these things you've learned about, like oscillating color, lerping color, transition, all of that stuff that you do in any kind of 2D, you can do with the lights as well. So you can make all sorts of beautiful, crazy, psychedelic, colorful, three-dimensional scenes by mixing lots of different shapes and lots of different lights. Okay, so share with me what you make just with materials and lights. See if anybody can make something that demonstrates the difference between specular material and ambient material a bit better than I did in this video. I'd love to see that. Please share it with me. And I'll see you in the next video where, if I haven't said this already, I come back and talk about texture, and then in a follow-up also about camera perspective. Okay, thanks for watching. See you soon. Okay. The sun is green. Everybody's freaking me out. Okay. If I have an ambient white light, it's going to wash out all the point light. That is a good point. Very good point. Okay. So now, we are done with that. What time is it? Almost 4 o'clock. So now I want to talk about texture. Now here we might be in the situation where I haven't tried doing texture stuff in P5, WebGL. I'm going to leave this here, and what I'm going to do, let's go get the kittens. I think the kittens are what we've got here, right? So somewhere, desktop, past, Chrome extensions, kittens. Wait. I think I did an example more recently where the kittens were, oh yeah, here. Object, images, kittens. All right, let's go grab the kittens. And let's go to here. Just out of curiosity, before I do this video, let me do a couple tests. Let's do some tests here. John, before I do the tutorial, why don't I actually try to test some stuff. Let me run a preload. Oh, I got to switch my Yes, thank you for reminding me about the battery. That was Gregory KXK. Kitten. Kitten equals load image kitten 0.jpg. So okay. So let me go back to here. And it's in the directory. So this I'm going to kind of just test some stuff out without explaining it too much. And then I will come back. Boy, I'm terrible at this. Okay, so the kitten loaded. Just out of curiosity, does the image function on its own work in WebGL? It does not. So the image function does not work. The texture function should. Okay, and how do I make a plane? A plane, let's look at Simon's cheat sheet. With height. Okay, oh right, because it's just the width height. Okay, 200, 200. Oh yeah, Superman 3. There we go, there's the kitten there. Oh, the light is all weird. There we go. Okay, so that's how you would just draw an image as a texture to a plane. So that I might start with. I'm also curious, does begin shape, can I do custom shapes? End shape, vertex, -100, 0. What do I want to do? Clockwise, counterclockwise? I have no idea. Let's try this. Let's first get rid of the kitten. Okay, so that made a custom shape, and I could say fill or give it a text. I'm just curious if all these things work. That didn't work. Do I need to put that after begin shape? Let me make sure I'm in the, yeah, I'm in the new version, okay. So this might be something that needs to get worked on in terms of, let's try a normal material. So I couldn't get a normal material for a custom shape. That's weird. What about ambient material? Nope. So this is interesting. This is something that has to be looked at. The material for drawing custom shapes. Burger. I read the chat very rarely. Models is interesting. No, I have texture commented out on purpose. I'm pretty sure texture is going to work. No. Do I need light? So I think I'm going to stay away from doing custom shapes because that doesn't seem to be working in the way that I expect. I'll have to come back to that another time. I'll have to investigate that if I'm doing this incorrectly, if there's a bug. But I am pretty sure. If I do this, all right, so, and let's put this stuff back in. And let's take out this light stuff, comment that out. And let's try this. All right, so that works as expected. Does it automatically know how to texture? Oh, wait a second. I forgot the UV coordinates. That must be why. Oh, okay, hold on. Let's go back for a second. Okay, so I forgot the UV. Let me look at the reference. Texture or vertex. It doesn't have it documented as having UV coordinates. Let's look at texture. Yeah, the examples are just showing using, and it's cool that you can use a video. I will show that as well. The examples are just showing oh yeah, sorry. Thank you for noticing my chroma key issue. Let's see here. Let me just look at the examples. I know how to do this. It's interesting because I know how to do all this stuff in processing, and I'm kind of learning now what works, what doesn't. Where are the WebGL examples or texture? Textures. Oh, look at these. Let's look at these for a second. Whoa. So yeah, this is just showing with pre-baked shapes, which is fine. So I don't know. Let me just try this one more time. I'm feeling this hasn't been implemented yet. Oh wait, where am I now? Whoop. Okay. So what I realized I was missing was typically with a what's this? 100 by 96. With a when you do texturing and you say I have this image and then I have this shape, I need to, in addition, it doesn't just happen automatically. It knows how to do it automatically for certain kinds of shapes, but I have to say for this vertex, for this particular vertex on the image, on the shape, I want to assign this pixel from the image. So in that case, I would have to say, I need to give it like, that goes with pixel 0, 0. This goes with pixel like 100, 0. This goes with pixel 100, 96. And this goes with pixel 0, 96. Now I have a feeling this has not been implemented. This is how it would work in processing. Yeah, so that didn't do anything. Sometimes those UV coordinates are normalized. So I would say this. Sometimes it only, oh, look at that though. What is it? I'm seeing something there, right? That's coming from the image. Do I need to give it like a material? Weird. No. Did I get these UV coordinates wrong? Fill? So I think it's just not. Models is the way to do custom shapes in 3D. But how do I create a model? I don't believe model is the way I could load one in. Load path, draw a model, yeah. So I don't know. Okay, so I could get into that. Yeah, so I'm just going to, yeah, no stroke. Oh, could the plane be, no, that can't possibly be true, right? Okay, rather than continue to, hopefully not waste, but continue to take up all this time, I'm going to talk about textures and loading images just for the primitive shapes. And I'll mention that something about coming back and doing custom geometry another time. So Simon is pointing out that you can load a custom shape with an OBJ file, but what I want to do is generate the geometry algorithmically, which is something that I know I can do in processing using begin shape, end shape, and 3D vertices. And I will investigate the close. I don't know, maybe the close. It's just the vertices, doesn't fill the inside. You're creating an opaque object on the image. I'm trying to do texture mapping, but I'm going to... You can all go and watch my video with the flag waving thing in processing to see how that worked there. And I'll investigate this another time. Okay, so now what I want to do is just get back to what I was before. Oops. me just put it back to something. Okay. All right. Nope, ambient material. Take out this fill. Take out this plane. Oh, the ambient light is, oh yeah. This is what I wanted to do. Okay, this is kind of where I left off. Okay. Please go fix the word camera. Oh, on the, what, here? Is it really that awful? Usually I'm the one who's crazy and bothered by stuff like this. There. Does that make you happier? All right. All right. Here we go. Hello, I'm back. In this video, I'm going to attempt to explain something and also implement something, and that something is textures. Good timing. Time out for a second. I'm just going to start over so Mathieu doesn't have to edit everything. Hello. In this video about WebGL in P5, I'm going to attempt to explain something and implement something, and that is adding a texture to some geometry. So I'm kind of checking off this list. And by the way, a couple things that I've now realized I've missed is I've only shown you in terms of geometry primitives. And there are some other ways, right? In theory, I think this might be, at the time of recording of this video, a little bit buggy because I've been doing some experiments with it. There's no reason why I couldn't use begin shape and end shape to create custom geometry, right? To create my own algorithmic 3D shape in WebGL. So that's certainly something that should be on the horizon for P5. And in addition to that, I could also use a function called load model. So if anyone wants to make like a nice model of a train or something, send it to me. Maybe I'll make a video that loads. And I think typically there's probably a bunch of different file formats of 3D models, but certainly one that I believe works with P5 as an OBJ. So if you're making a 3D model in some other 3D authoring software and you export it as an OBJ file, you could import it. So, but what I want to focus on here is texturing. And what texturing is instead of simply having a material, this sort of, that is just a color or a certain kind of reflective continuous surface, that you can actually take an image, something that you loaded, it could be a live video, recorded video, or a static image, and wrap that image around the particular shape, whether it's a sphere, a torus, a box, a plane, etc. So I want to look at that texturing an image. So let's go look at how we do that. And to simplify things, let me actually first start off by just making a plane. So I'm actually going to make a plane. A plane is a geometry that's just a flat plane, and I can give it a width and a height. So I'm going to just say 200, 200 to make a square plane. So you can see here's mine. This is very similar to just drawing rectangle. But the fact that I'm using plane, one of the 3D geometry primitives, means I could actually texture this right now. And you can see it's responding to the light. The light is still in the scene. So I'm going to leave the light in the scene for right now. I might take that off. So now I also happen to have a directory of images. I don't know. Does anybody have a favorite kitten they want to see right now? I think, well, let's just go with kitten 0. It's cute kitten 0. Okay, kitten 0 is going to be our texture. So what I'm going to add now, avert your eyes. So what I'm going to add now is I'm going to add preload. Preload is a function in P5 that allows you to load data assets, media assets, other things that are ready before setup and draw happen. So I'm going to make a variable called kitten. And then in preload, I'm going to say kitten equals load image. And I had a directory called kittens. And I had a file called kitten.0.jpg, kitten0.jpg. And now what I'm going to do here is I'm going to comment out the material. And I'm just going to say texture kitten. And the magic will happen. We're going to see our kitten. Oh, interesting. So the kitten is like, so interesting. Look at the image itself is responding to the light. So one thing I want to do right now, just to simplify things, because I don't want to worry too much about light, is I'm just going to create ambient white light and take out this directional light that I worked on in the previous video, just to simplify things. And so now we can see there's our kitten. Ah, it's spinning off as like in the end of Superman 3, which is a movie that I seem to reference way too often in my videos. General Zod the kitten. Okay, so what else can we do? Let's just try some other shapes. Why not? Let's try box. Now we have, oh, and let's make the box a little smaller. Now we have that kitten image on all sides of the box. Let's try sphere. Now we have this. Now here we're seeing something that's now happening. So P5 in the WebGL renderer is making a decision. It's like, well, here's an image, here's some geometry. This is my best guess as to how you intended to wrap that image around the geometry. And in this case, if I wanted to make this appear like a planetary surface, for example, I would get actually a spherical polarized image of like a texture map or something so there's a lot of work in terms of how you might want to design images that work well in certain contexts, but we can see that that just works. Let's just see I'm just here for all the shapes. Torus. So you can see there's the kitten wrapped around the torus. We can stop this now. So I'm going to go back to box. Oh, and you can see here, even with different dimensions, it's doing different things to the kitten. So I'm going to go back to box 100, and there we go. So now I want to look at some other things. What's interesting about this is there's no reason why we can't use a video source. So if you look under create video or create capture, let's try to use create capture. So I'm going to say in setup, I'm going to say let cam for camera, cam equals create capture. I'm going to say 200, 200. Oh, wait, no, sorry, I don't give it a size. Video, I think that's how I do it. Create capture video. Let's just see what happens here. So where is my, oops, track start error. Hold on. Did I just say cam.start or something? I don't think so. No. I probably just wrote the wrong piece of code. Pick a random kitten, yeah. Begin shape and close shape. Ah. Oh yeah, Austin, I'm going to be doing iTerm in the next session. Definitely the next session. Thank you for this. I'm seeing in the chat, BramVG has sent me an example that uses custom shapes. I'm going to drink some water. I really do need to drink water. Why is it? Am I like parched in a weird way that I'm like, are you just like being kind and thinking of me? Wait, hold on. Why is my create capture off? Oh. I need to go to the DOM library. Oh, I do need to give it? No. So why? What's wrong with this? Hold on a sec, everybody. Oh, no. Why am I getting this error? Don't tell me capture is somehow like not compatible with WebGL or whatever. End shape. I just need end shape close. Interesting. Okay. Why am I getting a user media error? It's really weird. Oh, debug, 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 debug. Debug, 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 debug. Do I just need to like restart my browser or something? Am I using like an old version of the DOM library? So weird. Yeah, but there's no reason why it wouldn't work with, if I take out WebGL. All right, hold on a sec. Let's not go too nuts here, and let me go to let's try that. So this is okay. This makes me feel a little better. I think something is going on this computer. So hold on a sec. Let me quit Chrome. Huh. I guess I don't think I need to give a size. It should do a default size. All right, I'll try that. I've done this without size. No, I'm getting a... Right, like, for example, if I just go to any... Yeah. Let's see something here, QuickTime. Oh yeah, look at this. What's happening on my computer here? FaceTime, built in. Did I disable it? Oh, it's something else using the, all right. Dare I restart this computer? All right. Oh, if I restart the computer, it won't be able to hear the sound anymore. Oh, wait! Please, hold. Please hold. Woo, did you hear that? I'm restarting the computer. The sound just came back for a second. All right. Oh my God, oh, my back. Ah, the pain, the suffering. Oops. Ah. There we go. Oops. Okay. Let's see. There we go. Here I am. I'm like Beyonce with my background and no music.
Unicorns and rainbows and cupcakes. What else is there?
Ooh.
Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it.
Okay, let me get back to things here.
Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens. Kittens and 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 kittens and kittens and kittens.
There we go. All right. We're back in business. So So that was just a temporary glitch. All right, got all my tabs open, and all right. Okay, so by the way, I seem to have some new viewers today saying if anybody is like a sound music person and can help, I'm a little bit like obsessed with all my weird sound effects, but they've all gotten stale and I need some new ones. If anyone wants to help me with that, please, I would love that. I just don't have the time. I mean, I should make the time. I have the time, it's just not a priority. I mean, maybe it should be a priority, I don't know. All right, so I think where I last left off was, I'm gonna just go from here. Okay, so let me take this out for a second. Mathieu, this should be go from wherever I added this and it didn't work to it working. Okay, so we should see, there I am. So this is the capture element. It's a separate DOM element that's taking the live webcam feed. You can now see my secret green screen here. I have an itch. Wait, no, okay, wait, no, okay. I scratched your head, I scratched your head. Okay, sorry, back. I forgot that I was making a video tutorial. It just went off in my own world. All right, so a couple things. One is, let me just make that a little smaller, just so we can kind of see it there, but not have it overall on the screen. And then now, what I want to do is, can I make this video a texture on the box? So I don't see any reason why I couldn't just change this from kitten to cam. There I am. Oh, I could do my Superman 3 thing now. Please, just humor me. Just humor me. Turn off this video, go to something else. I'm going to do this for my own personal enjoyment. Wait. All right, never mind. Okay, moving on. So you get the idea. I can take, and by the way, if I wanted this to appear less, I don't know what I want this to appear like, but I can use cam.hide, in which case I could actually only see the video texture on the box. So this is a way you can take any image, like a live video and texture, and I could change that to a sphere or a torus. I do want to, again, at some point begin, oops. I do want to, at some point, look at how I can start to assign image textures to custom drawn shapes with begin shape and end shape. So I need to approach that in a separate video and just look at loading models and custom shapes. So somebody remind me if that video doesn't exist in this playlist to do that. Otherwise, you're going to see it at some point in a few videos from now. So I'm going to quickly check to see if there are any questions or points that I forgot from the live chat that's going on now. Otherwise, this video will end. All right. Can you use, is there anything that I should demonstrate here with texture? Should I add the light in? What do you mean by a simulated light? Begin shape triangle for custom shapes, okay. This is the one time where I didn't actually miss anything. I said, like, I didn't end the video prematurely. I'm looking at the chat. How does light affect the texture? Okay, okay. Can you have a shadow? Well, oh yeah, yeah. Oh, I could put a plane. Oh yeah. Okay, let's try that. All right, so I'm back at the end of this video. I'm not sure exactly why, but two questions came up in the chat. One is, how do lights affect texture? And two, what about shadowing? So just out of curiosity, let me try putting a plane at the bottom. So what I'm going to do, just to show you a little more sort of 3D stuff, I'm going to say, with this spinning cube, I'm going to put a push before and a pop after, so that the rotate does not affect anything that comes after. And then I'm going to add this plane. So we should see here, oops, there I am, but I want that plane now to look as if it's a floor, maybe. So what I want to do is translate maybe all the way down to the bottom, and then rotate if I want to take this plane and rotate it like this to be flat, I want to say this is the x-axis, so I want to rotate x, and rotate it basically 90 degrees, which is a half pi. Let's try that. So you can see there it is. Now I don't want, what I want to do also is maybe only translate it 100 down, make the plane like really, really big, and maybe I want to give that a ambient material, so it doesn't have a texture of white. Is that going to override the texture? Whoa, bugginess. Okay, great. So we can see now that there's like this floor. Making it white made it a little confusing, but let's make the background, let's make it, that's fine. So what I want to do is let me try to add some light. There's an ambient white light right now. Let's take out that ambient light. And you can see the floor, it's not buggy, it just takes a little while for the video to start. The floor is now black. But it does have an ambient material of white. So let's try adding this directional light. So this is a directional light that I did in the previous video, which just shines a light from far away at a given direction based on the mouse. And I'm going to let's make that light white. Just to, and I'm going to just give it, I might be able to give it just 255, but I'm going to give it all three. Let's give that a look. So you can see now, look, that light is shining and it's only able to see the sides of the cube where the light is. And you can see there is shadowing going on based on the light. Now, the thing is, the shadowing, I probably have to be more thoughtful about the positioning of these objects in order to get the shadowing to work in a way where I might actually see. But I'm going to let that be an experiment for those of you. Could you try using maybe a point light? Like, for example, let me just actually do that. Let me add a point light, and let me put that point light a little bit above. Yeah, now you can see a little bit more, like you can see that there is maybe some shadowing, but maybe if I were to, I really should stop what I'm doing, like translate the box a little bit back, maybe like a little bit down, and a little bit back. I put it in a weird place. So I'm again, I'm going to leave this as an extra. Hold on. Let's go back. Let me not try that, because I don't know what I'm doing here. So I'm going to leave it to you as an exercise to try seeing what you can do with point lights and ambient lights and different shapes to see if you can get shadowing. But you can see sort of the stuff that you've got to play with here. In terms of having a light that's shining into the scene with different shapes, with different materials, and different textures. Okay, thanks for watching. All right, shading, not shadowing. Thank you. That's probably a good point. Oh, and I forgot to add shaders to this list. All right, we're going to do camera next. Let me switch this to a point light. And just put it at the top. And make the background. I'm just going to change this a little bit to make the background 0. Okay. And it's a point light. And what if I... Oh, and I translated it in the wrong place, I think. What if I translate this back a little bit? There we go. All right. So now what I want to do is, let me take that out. Okay. Yes, you can modify the texture with a shader, but I'm not going to get to that. So the next thing I need to look at is camera. So what are the functions? You didn't see me change the thing here. The next thing I need to look at is this. And then these are some things on my list also, as well as I'm going to add shaders to this list. Sort of getting to the end of today here. So, and we'll see if we can fix we can see if we can investigate that point light bug and see where that changed. All right, so here's the thing. I don't know how this camera stuff works. So let me look, camera. Camera in view. There are 3 camera functions. Camera is perspective with a 60-degree field of view. So that's like this. Oh, I'm in the wrong camera. Speaking of camera. Sorry, everybody. I really have a lot of trouble remembering. So there's perspective. To override the default camera, simply call perspective or ortho. In perspective, objects closer to the viewer in the z-plane appear larger than those farther away, right? In orthographic view, objects of the same dimensions appear to be the same size even when they're farther away. That would have been a nice way to describe that when I did that other coding challenge. Sorry about that. For more information, check out the excellent P3D tutorial here. What's funny is I'm acting like I don't know this stuff, but apparently I wrote this P3D tutorial. It says my name there. Camera. Perspective. Okay, see, yes. Ah. So we're going to look at this. I'm going to look at perspective and ortho. That's going to be helpful. Camera, eye position, scene center, upwards axis. See, I know how this works in processing. Is it exactly the same? Let's look at Simon's cheat sheet here. X, Y, Z, center X. Yeah, so that's the same. Perspective, field of view, aspect, near, far. Ortho, left, right, bottom, top, near, far. Okay. So what's a good way to demonstrate this? So I think one thing I should do, by the way, is maybe I should go back to the kitten. I don't know if it's going to be simpler, and then I should just probably say ambient light. So is it going to be simpler to see these differences without a texture on the image? Probably, right? So what if I just change this to, as much as I love the kitten, normal material. So this is probably a better way to look at it. Okay. And then let's look at some things. Like, for example, let me just play with some ideas. So let's see what happens if I first say camera. So if I were to say camera mouse X 0, 0, what are the defaults again? Let me look at my tutorial. So I'm pretty sure this is the default camera. Put the light after it. Ooh, DX is not defined. Why? Oh, I don't need any of this anymore. Whoa! Okay, wait. Default camera. It would be different. 0, 0. Right, 0, 0, right? Ooh, weird. Maybe these are supposed to be 0, 0 now too? Because of the... There we go. That's the default camera, right? The default camera. Comment this out. Exactly the same, right? X, Y, Z. Okay, so X, Y, so what is it again? It is X, Y, Z, so X, Y, Z is where the camera is. Center X, center Y, center Z is where the camera is looking. And then up is like the direction of up, because you need all this. If you think about it, if this is the camera, you need to know where is it looking, and which way is up? Is the camera on its side? So for example, if I were to put mouse X here and go back, this is me moving the camera. It's still looking at the same. What's weird is it's not panning because it's still looking at the same center point. Right? You can see how that it's kind of moving to the edge, but it's still looking at the same center point. So if I wanted it to also look at a new center point, that's me panning. Okay, so this makes sense. I could also zoom the camera in. Whoops. By saying like mouse X. I'm just trying a few things before I make a tutorial about this. Whoa, what did I do wrong? Uh-oh. 0, 0. Oh, right, this, sorry, that's there. So this is the default location. People are sending me things, okay. That's the default camera. So I could replace this like with just like mouse X. Whoa, it probably can't be 0. Plus 10? No, why couldn't it be? Yeah. That's weird. That's a bug. Oh, it can't be in the place where it's looking. So it probably should give you an error. Okay, so probably let me add this to the list. Oh no! Hopefully I didn't lose my shoot. Because I just like force quit the computer. Oh, WebGL issues. No, there it is. So error if camera XYZ and center XYZ are the same. Okay. So that's camera. So that I can make work. Is this documented in a better place? Perhaps here? Okay, ortho I know to get perspective. Field of view. Okay, so let me go back to this tutorial. Camera. Do I do field of view in here? Yeah. So let me just look at this for a second. So this now is field of view. Oh boy. Let me just perspective, field of view, width divided by height, camera Z time. Let me just look at this for a second. Okay, that's the default field of view. Now if I were to change this angle to like map mouse X between 0 and width to between 0 and pi divided by 2, that's just changing that. It's like zooming because I'm narrowing the field of view. If I didn't change the camera Z based on that though, if I just made, wait, what's the near and far? Is perspective near and far? Aspect near and far. If I change that near and far, if I make those fixed, near and far, then what I would see, right, I'm going to get some weird stuff going on. All right, so that's, I think I'm going to probably not, I think I'm going to mostly work with the camera and skip the perspective stuff, but I do want to look at ortho. So there we go. So this is harder to see just in this particular example. Interesting that in ortho, do you all know why I can't see that plane? Because in ortho, that plane is flat. I don't see it from above. It's perfectly flat. So the fact that I rotated it, if I rotate it by quarter pi, then I'll see it there. So ortho is going to become much more apparent when I draw a bunch of these at different distances. But so I'll try to maybe do that as well. Okay. All right, I think I'm ready. All right. Let me just, it's 4:40. I've got about 20 more minutes or so. I wish there was something more. Okay, so we're going to do camera stuff now. Okay. All right, I'm back. Again, I'm kind of going through my list of topics about 3D and WebGL with p5.js, and I'm now on to camera. So in this video, I'm going to talk about camera. Now, there are three functions that are important to look at: camera, perspective, and ortho. I recently did a coding challenge, which I will link to from this video, where I made heavy use of ortho perspective, and I did a kind of terrible job of explaining it. So I'm going to try to come back to that in this particular video. But let's start just with the camera function. So the thing about a camera, actually, so let me do some... So hold on a second. I think a diagram would be helpful here, as difficult as it is for me to draw anything that is remotely close to 3 dimensions on a 2-dimensional whiteboard. But let's just pretend, for example, that this is the scene that I'm looking at, right? And that's the cube. And what I want to do is there's this idea, this is a made-up concept of a camera. There's a camera over there. I should turn it towards, I'm out of the picture. There's this made-up idea of a camera, which I'm going to draw like this. What might not be immediately obvious to you is there are a whole bunch of properties associated with this camera. For example, this camera is at a particular location. It's at a particular XYZ location. It's also pointing in a particular XYZ direction. So a camera, you can think of this marker as the camera. It's pointing directly at you, and it might be closer to you or further away. It might be up here, but pointing at, at the ceiling. So I need to, when I have a camera, I need to define where everything is in the scene, then where the camera is or where it's pointing. But that's not even all. I also need to define a vector that points up. Because now if you think about it, right, if this is the camera and you were to, this is a terrible idea for me to pick up this camera, rotate the camera, right? Oh, everything's going to go to hell in a handbasket. Oh my goodness, it unplugged. That was totally a bad idea. Okay, time out. I caused many tech. Oh, it's back. It's back. Okay. The camera's all messed up. This was such a bad idea. Whatever. Good. Close enough for now. Oh my goodness, it's totally in the wrong place. Time out. Time out. Technical malfunction. Is that about right? I'll turn it even a little more. Okay. I'm the worst. By the way, do you know that I have a chair here? Someday I'm going to use this chair. So, as I was saying, okay. All right, apologies for the technical camera mishap there, but you can imagine, right, if the camera's turning, is it looking on its side, is it looking straight up? So that vector pointing up tells us how we're supposed to turn. So we need all 3 of those properties. We actually need, and this is also an XYZ value. So the camera actually needs, to set a camera, we need 1, 2, 3, 4, 5, 6, 7, 8, 9 arguments. So let's go back and do that. Now here's a scene that I've set up. It's mostly the same as the previous video, but I'm just using a normal material as opposed to the video texture. Now here's the thing. Watch as I magically add a camera to this scene without the camera function. This is going to blow your mind. At the very beginning, right up here, I'm just going to say translate 0, 0, mouse X. Whoa, look at that camera zooming in and out of the scene. So it's really important to realize that this camera is an artificial concept created by us to create the illusion of a sort of pair of eyes, or a single eye really, in the scene. I guess it's a pair because you're seeing depth. Anyway, to look into the scene. But if this is my three-dimensional object and this is my camera, what's the difference between moving the camera towards it or moving the object or the whole scene towards the camera? Those are the same things. So you can do a lot of camera work and moving things around and changing the view by just manipulating the rotation, orientation, and position of everything in the world. But sometimes the camera function can actually be quite useful to do certain things that wouldn't be as easy to do without it. So let's take a look at how that works. Deep breath. Okay, so now I'm going to go back. I'm going to take out this translate, and I'm going to add the camera function. Now, where is the camera? Let's put the camera at 0, 0, 0. Now, where should the camera look? Let's have the camera look at 0, 0, 0. Oh, and which way is up? Let's have the camera point up 0, 1. 1 points up or just 1 point down? I don't know. 1, 0. So this is just about right, the default camera, except for the fact that what this is, again, if this is my object, my scene, I just put the camera right here in the same place. I actually want the camera to be a little bit out. The camera is, by default, out. And I think there's like a specific value for this, and I always forget what it is, so I'm going to pull it from a processing tutorial that I will link to. Whoops. So I'm going to come over here. Hold on. Yeah. Sorry. So I'm going to pull from a processing tutorial that has a lot of information about 3D. I'm going to just grab this value. So this is the default Z location of the camera. 0, 0, and then I put it here. So it's the height divided by 2 divided by tangent of pi divided by 6. There's probably a better way to write that, some sort of magic number. And now I'm going to go back to the sketch. We should see this is exactly as it was, right? So I'm using the camera function. If I comment out the camera function, there it is. It's the same scene, but now I can start to move the camera around. For example, what if I actually put the camera on its side? Like pointing to the right. Right? Now I'm looking at the scene, I just turn the camera over, and we could actually animate that and have it bounce around as if it's like a shaky, we could have a shaky camera. Ooh, that's kind of like a fun thing to try to do. Again, this is no different than rotating the whole scene, but I'm using the camera object to do it. Let's put that back to pointing up. What if I were to move the camera along the x-axis? So I'm going to say x equals map mouse x, which goes between 0 and width, to between like negative 200 and 0. So I'm going to kind of like move the camera to the left as I move the mouse. This is sort of silly. Whoops, I have a syntax error. 0 width, negative 2. Oh, this should have x here now. So that should probably say camera x just to be kind of consistent. So now we can see, look, it looks like it's spinning, which is kind of weird, but you have to remember that where the camera is looking is still at the center. So what I'm actually doing is this, right? I'm doing this, right? It's always looking at the cube. It's just moving to the side of that plane. You can kind of see it. You can kind of imagine that. And again, if I were more thoughtful about this, I could probably create a better visual demonstration. But what I could also do at the same time is move where it's looking. Remember, this is the sort of look at location. It's called center X, center Y, center Z. It's the look at location. So I have where the camera is, where I'm looking, and then the orientation of the camera. So now if I did that, this gives me a pan. And for some reason, I did this in inverse. I didn't mean to do that. So let me just, I think what I meant to do is this. Yeah, so I don't have it backwards, which is not a big deal. But you can see now I'm panning back and forth. And I could do something like I could have it rotate as I'm panning. You can imagine there's a lot of possibilities. So that's what the camera function does. This merits probably some kind of coding challenge where I attach the camera to some like moving thing throughout a scene. Oh, we can make a shaky, let's just make a shaky camera because that's kind of could be fun. How would I make a shaky camera? Let's have the camera x equal random -5, 5. Let's see what this looks like. And camera y also equal a random amount. We could use Perl and noise to have it be. And then I'm going to give, oh no, the z, I'm going to make that just like an offset. So I'm going to put this in, and let's have it continue to look at the center. So it's like so you can see, is the scene shaking? Is the camera shaking? I don't know, but you can see. Now I probably could have like do something weird, like mix these values up. So I could have it like look in the slightly like, also in a random direction that's slightly off. So I don't know. You can see here, earthquake, earthquake. So I've used the camera now to make kind of a little bit of an earthquake simulation. Okay, so that's camera. Did a couple more things with that. Let's comment that out. So one thing I want to just mention is perspective. Oh, I don't want to. Do I have to? Timeout. Thank you, Alka. -1 on y should be the sky usually. Yeah, I don't know. I'm just looking at the chat. All right, what's going to be a good demonstration for perspective? Let me look at my processing tutorial. Why do I have perspective first in this tutorial? Field of view, aspect ratio, near and far. So the parameters define a viewing volume with the shape of a truncated pyramid. Objects near the front appear their actual size, while farther objects appear smaller. Field of view and ecliptic plane. All right, all right. I think I've got it. Oops. All right. Next, I want to talk about perspective. Now, perspective is separate from the camera. Perspective is a function that defines how that illusion of three-dimensional perspective is created. And it involves a couple things. It involves a field of view, which is really a pyramid. But I'm going to draw it kind of like a cone, or a two-dimensional cone, right? So that field of view could be wider, or it could be smaller. And then it also defines the clipping plane. So in other words, maybe actually anything that comes in front of this near point I don't even see, or anything that's past this far point I don't even see. So there are defaults. I also need an aspect ratio, I think, which generally would be tied to just the aspect ratio of your canvas. But there could be some nuance there, I'm sure. So I have to admit that I don't know that I'm not really a 3D. I'm not really a 3D person, so I have done some examples of things. I don't think that I've ever used the perspective. Maybe I've used it to kind of expand the clipping plane, the near and far points, or to shrink it. But generally, I'm always working with the default field of view. Let's try to just at least add it, though, to see what we get. So if I were to add the perspective function, let's get it working with the default perspective. So the default perspective, and I'm going to go back to my processing tutorial to get these default numbers. And I'm going to just copy that in here. And I'm going to change that. The processing P3D renderer is a Java programming environment. So I need to just quickly change this to be compatible to, so basically, the default field of view is a 60-degree angle, or pi divided by 3. The camera Z location, right? This is actually something that I already added up here, right? It's the same as this, right? So that is probably, so that's kind of the default camera Z location. And so that's how I'm defining, that's how I'm defining the clipping plane. It's the camera divided by 10 and the camera Z times 10. But I could make these arbitrary numbers. But let's just at least look, and then aspect ratio is width divided by height. So let's look at how this looks. So we can see that's the default perspective. Let me just, for the sake of argument, make the near point, is the near point like minus 500 and the far point 500? So we can see I haven't clipped anything. Let me make that minus 50 and 50. So I don't know if you could see, did that clip anything? 10, it's got to clip something at some point. Am I doing this wrong? Why is that not working for me? Right? If I make near and far 0, is that just a bug? No, all right, Mathieu, we're not gonna change those values because they don't seem to be doing anything right now. Did I? Oh, thank you. Let's go back. Thank you for noticing that. Let me just see if it actually works. 10 would be 10 units in front. So is it 10, negative 10? Still didn't do anything. Whoa. I don't know what I'm doing. And I clipped everything out. Huh. 10 to 30 gives 120 buffer. Distance relative to a head. Anthony writes, coding without a battle plan is asking for trouble. Truer words have never been spoken. I'm definitely asking for trouble here. All right, maybe I don't want to talk about, let me put it back to what it was. Think about what it was. So it's camera Z divided by 10. So that camera Z location, if it's like, let me console log that. What kind of number is that about? So it's like 260. So this is basically 26 to 2600. So this is small and this is big. If I were to make this 500, what if I make this mouse X? Oh yeah, we can see it clip it away. That'll be a really quick demonstration. Okay, so let's do that. Okay, so now we have the default perspective. So the first thing we could experiment with here is like, so that clipping plane is defined by where the camera is because you want to see something based on the camera. But for example, what if I just take the far end of the clipping plane and assign that to mouse X? I can now see, right, as I move the mouse, it kind of clips. It's sort of like taking away what I can render. So this is generally something that I don't play with because I just want to like see the whole scene. But sometimes in certain situations you might need to deal with it. Another thing that we could play with is the field of view. So what if that angle were a lot big? What if right now I'm looking at 60 degrees, pi divided by 3. What if I had a 180 degree field of view? Let's just change that. Whoa, I don't actually see anything. Did I put everything back? So hold on. What if instead of having a 60 degree field of view, I had like a 30 degree field of view? So it was shrunk, or even like a 10 degree field of view. So this would be pi divided by 6 would be a 30 degree field of view. And you can see the field of view has shrunk, so it actually looks kind of like I've zoomed in on it. Also, the clipping plane was changed. So because the clipping plane is being defined based on the camera, which would be defined in the field of view. So this is a little bit kind of nuts here. But let's try to do something by just say I'm going to have the clipping plane between 0 and 2000. I'm going to put the field of view back to 60 degrees. And I'm not going to actually move where the camera is. I'm just going to leave the camera at as if there was a field of view of pi divided by 60 degrees. So that camera, and actually, so sorry. What I want to do, let me back up for a second here. What I want to do to demonstrate this, I think this is going to work, is that I want that camera Z location to be fixed. So I'm going to store that, and so I'm going to just put in pi divided by 3 here. Now what I'm going to do is I'm going to have the field of view be a variable that changes with mouse X between 0 and pi. So now what I should see is, look how that perspective changes. Like this is a 180 degree field of view, And that right here is about 60 degrees, and now it's sort of like my field of view is narrowing. Now the camera is actually not moving here, but based on the field of view, we're seeing kind of a different volume and it appears closer. So this is kind of a complex topic, and I think I've kind of overemphasized it, because really what I want to talk about, which I think is much more important or interesting to play around with, is orthographic perspective or orthographic projection. In other words, with perspective, with traditional perspective, objects that are farther away appear smaller than objects that are closer. That's how we create this three-dimensional perspective. With orthographic perspective, objects that are farther away are the same size as objects that are close. They might be different sizes, but if they are actually the same dimensions, they will appear to be the same size. And this creates kind of a flattened 3D look. And this is a classic 3D look that you'll see in lots of certain game designs, most famously probably Qbert. So, and this is called isometric view, is a particular camera angle. Whoops, shoot. This is a classic perspective projection that you'll see in a lot of games, like Qbert. So here's an image of Qbert. You can see how this has a kind of like flattened 3D perspective. So, and this is also referred to as isometric projection. So let's see if we can create, and this is what a coding challenge that I'll link to from this video where I do this, and create a scene that has this kind of perspective projection. So let me change now. I'm going to take this out, and I'm just going to write ortho in here. And you're going to see, oops, as I go here, I'm going to refresh. This is now orthographic projection. And what you see, it looks like it's skewed, but actually as the cube rotates and it gets further away or closer, it doesn't change its size. So this will be a lot more obvious if I put a whole bunch of these cubes. So what I'm going to do is I'm going to take out let me keep the rotate in there, and I'm going to make a little loop. I'm going to say for let x equal negative 200, x is less than 200, x plus equal 50. And what I'm going to do, and I'm going to put push and pop inside the loop. And actually, I also want to put rotate for each one of these. And what I want to do is I want to translate by x. X, 0, 0. So what I'm trying to do, let me take out all the rotate, and I'm going to make these boxes 50. What I'm trying to do is just put a row of boxes. So there's a row of boxes. We can't see that. Do I have it? Actually, I have ortho on. Let me take ortho off. You can see there's my row of boxes. Now let's actually see this perspective a little bit. Let's make the boxes a little bit smaller. Let me give them actually like an ambient material. And let me actually have a light, a directional light that's shining from, that's white, that's shining from like the corner. So like 1, 1, 1. So you can kind of see, and actually that light is way too bright. I'm really doing a terrible job of this. 3, 4, 5 triangle, right? But this is a three-dimensional vector. Let's just have the light come from the side. Oh boy. Well, time out. Let me go back to where I was. Let me add a, sorry Mathieu. And let me add a point light. Just that's white, that is above. That's like at 0, 255, 0, negative 200, and then from a little out front 200. So we can see here now, and it's I would like this, love this light. You can see, and let me make the background just a slightly different gray, so we can see what I'm looking at. You can see, there we go. So you can see this perspective. You can see how I've got this idea of sort of vanishing points, my eye looking at the center of this field of view. Let's change this to ortho. Let's put the rotates in. And we can see this perspective even more. Now let's change this to, and actually let me also translate along the z-axis, because this is going to be kind of key. So I want to translate along the z-axis. So where do I do those? Translate. I'm also going to translate that same x value minus 200 along the z-axis, and I'm going to make the boxes a little bit bigger. Whoops. Oh, x. There is no z. I'm going to just reuse the x value. So now you can see, and let me actually say x times 10. Whoops. Minus 200. Oh. X minus 200. Anyway, I'll keep them not so big. Okay, there we go. This is what I was trying to get for. So you can see this perspective as they get smaller as they go back. All right, we're getting somewhere. Now, bear with me. Let's turn on orthographic projection. Ortho. Now you can see, first of all, I have run afoul of the clipping plane. So I need to define the near and far point. Random might have been good. And so let me actually give this the ortho function. If I look at this WebGL cheat sheet that Simon put together, left, right, bottom, top, near, far. So let me say left, right, bottom, top, and then near, which would be 0, and far, negative 1,000. Is that right? Whoops. And what's going on over here? I did something ridiculous with my... This might be another one that I have to redo. Hold on. Try that again. Let's just first see if that works. What do I need it to be? How come I don't? Oh, there we go. Why? Near, far? Shouldn't far? I'm so confused. That's so weird. I'm just going to, and if I say this, oh, near to the camera, far from the camera. No? Interesting. All right, hold on. Go back to here. Thank you for the info about what I did the clicking wise. All right, so I've run afoul of the clipping plane. So if I go back to and look at Simon's cheat sheet here, which I seem to have lost. Oh, no, here it is. I can see here, left, right, bottom, top, near, far. So I can need to define the volume, the box where everything I see lives. And so I can say right now, I want to go left, negative 200, 200, top, negative 200, bottom, 200, or is it the other way around? I think it's the other way around. Top, I don't know. Let's just, and then I'm just going to give myself a really big space, negative 1,000, 1,000, just to not worry about it too much. And I'm going to go back to the sketch, and we can see, there we go. So you can see, even though those are going backwards, they're all exactly the same size. So again, have I really made the does my design that I'm doing really merit orthographic projection? Again, taking this out, we can see this is what the actual scene looks like. And for what I just did, I wanted to look this way to be able to see that difference. But there are some cases and certain kinds of flattened views of the world that are still have the 3D drawing but appear more flat that you want to use that orthographic projection for. Okay, so what am I missing? I now have done some tutorials about. We looked at 3D geometry, primitive shapes. We looked at material being sort of the skin of that geometry, lights being light into the scene, texture being a way of taking image data and wrapping it onto that geometry. So we've done all these things, and now in this video, I've mostly looked at the camera, which is a way of moving our view of the scene around, changing our field of view, or even changing the perspective, whether it's actual 3D perspective or orthographic projection. The things that I'm missing are how to do some custom shapes in 3D, maybe with textures as well, how to load a model from another environment, and also, I should add to this list, something called a shader. So this is something certainly that can be done in a 3D rendering environment. A shader can be applied to geometry in a variety of different ways. And so at some point, I would like to come back and do that. I will make a quick plug for the Book of Shaders. I think it's thebookofshaders.com. I'll link to it in this video's description. If you're interested in shaders, it's a great resource for learning about them. OK, thanks for watching this video about camera and perspective. All right. So I don't know. I'm gonna with these through this 3D stuff. This is stuff that I'm like learning new as I'm making these tutorials. So I feel like I did get through. I feel like today's session successfully talked about, you know, success is relative. But on the grand scheme of things, I was more successful, farther away from total success, but more successful with material, texture, and, material, lights, and texture. And I was less successful with this camera and perspective stuff. I think your clipping plane should be 0, 0.1, or 0.01 instead of -1000. Breaking news. I'm being told that this -1000 thing was like probably a problematic idea. But what if I put things, I don't know. So we're going to see if that's salvageable. The edited versions of these tutorials will get published in the next week. I think a new playlist needs to be made, which is just like a WebGL, p5 WebGL playlist. And I'll hopefully do more stuff. How to write text. Oh, this is so good. I forgot about something really important. Something you can do with texture and create graphics. Ooh, I should do a whole, I gotta save this. So I need to do a whole tutorial. What time is it? 5:10. I need to do a whole thing on create graphics. I'm gonna leave this here. I'm gonna come back to it tomorrow. So what do I need to do? Thank you for, texture and create graphics. So first I just want to do a tutorial about create graphics in general. Okay, that's going to come tomorrow. I think this we determined was just a bug. This we determined was just a bug in the old version, but it's correct in the new version. These are 2 GitHub issues that I need to file. So tomorrow I might redo the camera and orthographic projection tutorial, like do that again, maybe. I want to do these 2 things. I guess I could do the custom shapes. I feel like it's probably pretty buggy though. That's a very, the clipping is relative to the camera. Oh, that's the way to think about 0, far, near, far. That totally makes sense now to me. Thank you, Alka and Austin. All relative to the camera. That is excellent. Okay, hold on. Where's my breaking news soundtrack? Let me quickly correct one thing about ortho. The clipping plane, near and far, I can't believe I didn't realize this, is relative to the camera. So if I say the clipping plane is between 0, that's here, and between 1,000, that's kind of 1,000 units away, this sort of like vague 3-dimensional units away from the camera. So me saying like a -1000 to 1,000 is kind of pointless because now that's sort of behind. But what if you like rotate the camera or something? Maybe it would matter, but I don't know. So let me actually just put this back at 0, and I could say 0.01 maybe is most accurate, but just to see that is, yeah. So that's what I needed to do. I just need a further far value and could start at 0. Thanks for that. All right, maybe that'll get edited in, maybe not. Sorry. That's my electroshock therapy. All right. All right, so I feel that it is important here now. Let's see if we can look and see where this point light thing broke. So this is gonna be a little bit of a side. This could possibly be its own video, but I think maybe we'll just leave it in the live stream before I go. What I'm gonna show you now is how except I'm not very good at this, but I'm going to do my best. I'm going to show you how to try to look for where exactly something broke in an open source library. So I've done a terrible job. This, by the way, if somebody wants to help me out, I have done what I shouldn't do, what I said I wouldn't do, which is simply work with the same JavaScript file throughout a whole bunch of videos. So when I go to post all these code examples, I don't have them anymore because I've overwritten them. So if anybody who's been watching these live streams wants to help and help me compile the code, I'm getting a text message. This is important. I'm going to respond to it. Just sorting out what's happening for dinner this evening. Children need to be fed. Food needs to be made or ordered. It's all very complicated. Mergen in the chat Mergen says, I'm on it. So thank you, Mergen, for volunteering to do that. That's wonderfully helpful. OK, so wait a sec. I'm going to now, should I be so kind? Maybe I'll save this one. So what I'm going to do is, and Mergen, I can actually send you this one at least, if that's helpful. What I'm going to do is just make a separate folder here for WebGL debugging. And I'm going to go here, and I'm going to run a server. Boy, I'm never getting to that word2vec stuff, am I? And there I am. And yep, I'm using the current version. And now what I want to do, I just want to go back to a simple example where there are 2 point lights. -200, 0, 0, red. 200. All right, I don't know. So let's just pretend like this could be its own video. Yeah, so let me set this up. And it could just stay as part of the live stream. Sometimes, if it turns out to be this like really illustrative, useful thing, I'll keep it. But so sphere. So I'm going to say ambient material 255, sphere 200. And we're going to get rid of all this. Great. Really simple sketch. Whoa, I'm looking at the wrong. I'm totally editing the wrong file. So that's now the backup. The other one is the backup. Oh, I'm the worst. I'm the worst. I'm so bad at this. What can I do to ever make it go back? OK, let's take this and copy it. This is probably a terrible idea into here. Don't replace it. Don't replace it. Keep both. And then take this and copy it into here. Yes, and replace it. And then go back to here. Get rid of this one and rename this one. Then close this. Then go back to terminal. All of you are, I hope you're also pleased with yourselves that you have better workflows than me. OK. Whoa. OK, so some stuff I got to fix. Make the sphere smaller. No stroke. All right. So we can see here, I use version control. I know about version control. I can't bother with it during like live streaming. It would just take over everything that I do. OK, Mergen, great question. So at the moment, I would like the examples to work. So we should use whichever version of the library makes the example work. And then once the library is fixed, we should try to remember to put the corrected version of the library in. OK. OK. Hello and welcome to a debugging video. Maybe there'll be a new playlist about open source debugging and finding bugs and seeing if we can be helpful to the open source world. I don't know if this makes sense, but what I'm going to attempt to do in this video is, during my WebGL tutorial series, I noticed that in the current version of P5, if I create 2 point lights, one on the left, one on the left that is red, and one on the right that is blue. Oh, whoa, hold on. Oh no, that's the, sorry, that's the, excuse me. Do over time, please. This is the color, this is the position. I'm the worst. I'm getting tired. So I should probably do this tomorrow. Say what yes, thank you, Alka. Okay. I'm very excited about this video. I don't know if this is going to be helpful or make any sense. Maybe you're watching it, maybe you're not. I mean, you are watching it. Well, here's what I'm going to do. I'm going to try to have a new series, put this in a playlist, I don't know if series, about finding bugs in open source projects and contributing and helping to fix those bugs. Like, how do we do that? And this is going to be this is a high degree of difficulty one. So I'm not starting with something simple, and this will probably fail, but I'm going to do my best. So I just did a whole set of tutorials about WebGL. And in P5, and one of the things I noticed, with help from the viewing audience, is that if I put 2 point lights in the scene, here's a point light that's red, that's on the right side of the canvas. Here's a point light that's blue, that's on the left side, RGB, XYZ, and then I have a sphere with ambient material that will reflect that light. What do I actually see? I only see a blue light on the left. Now this is using P5 version 0.5.16. So let's just be sure about this. So I'm going to take this point light and put it second. Now you can see only the red point light. What I want to see, and I'm going to show you this really quickly, I'm going to go to my index.html file, and I'm going to switch. I'm going to talk about how I'm doing this. I'm going to switch versions of the library. This isn't working. This isn't working with version 0.5.7. So somewhere in between 0.5.7 and 0.5.16, this feature broke. I feel like I want some cool, Pink Panther theme song music to play, because we're going to do some detective work now. How can we find this? So first of all, how did I switch between the libraries so quickly? So one thing you might notice about this particular bit of code, you can ignore this kittens folder, but I actually have the p5.js library here locally. And that is the current as of the time of recording this video, version of the library. And in this, and you can see here, in my HTML file, I'm referencing that particular local p5.js file. Now, it's now commented out. I could comment it back in. What I decided to do, what's really much easier, is that I could use something called a CDN, which stands for Content Delivery Network. And if I search for CDN p5.js, what I'll get is this particular website, cdnjs.com, and it has hosted versions of the library that I can reference from my HTML file. And I can get the links for any old version. Now, one of the ways I'm going to do this right now is I'm just going to go here. I'm going to put 16 in here. And we could do this all day, right? I'm going to go back, to the sketch, hit refresh. It's broken. So I could say 0.15, still broken. 0.14, still, it's working in 0.5.14. So for some reason I went all the way back to 0.5.7 when I was doing my session, but now I can see it actually works in 0.5.14. So what does this mean? Time for me to go to GitHub. So the P5.js project is an open source project on GitHub. It's a complex open source project with many files and many developer tool, workflow crazy things. There's some documentation that's pretty good. There's some documentation that could be better that we're working on, that people are contributing to. But let's just go right now to the GitHub repository. So one of the things, this is the URL, github.com/processingp5js. One thing you should do is you should go click on contributors and just meditate for a minute and thank all these wonderful people who are putting in all these work. And I could say Karen, just to highlight some people, Karen Pang did in terms of WebGL, Karen Pang, Indefinite, and I think if we come down and find also Kate Hollenbach, right here. And I don't know what Stalgia is. Oh, Mind of Matthew did a lot of work in. Here's a Me I Am Sumi, a coding train viewer. So there's a lot of people on here that I'm just referencing some of the people who have done a lot of that WebGL work. So something I could do now next is I could just go back here to commits. Now here's the thing. I can sit here and look and look and look and look and look and look and try to find it and look at dates and commits. But there's got to be a way I can search for where this particular commit happened. So first of all, one thing I should be able to do is look for the tag for a release. So I think if I search for 0.5.14, and actually it's 0.15 that broke it. How do I look for a tag? A commit that has a certain tag. Maybe they aren't tagged. So maybe that's advanced search. I guess I could do, oh, tag, thank you. That's the releases. All right. So let me try to look over, the search didn't work. I think let's edit back, Mathieu, to the search. Click on releases on the front page. Let's do that. So let's go to try to search what happened with 0.5.15, let's go to releases. So we can see here's 0.5.16, 0.5.14. Hey, where's 0.15? That's weird. I don't know what I'm missing here. So normally you would think there'd be a 1.5 and, oh, yeah. Anyway, I don't know. Maybe my mind, the math in my mind is just. So we can see these are all the commits, 628 commits since this release. So we would think that in these commits, one of these would have broken that point light. Now, something that I could do, first of all, is I think an easier path towards finding this, though, might be where is the source code for point light itself? And by the way, this same bug, I think, happens with directional light. So if I go into source, maybe someone watching this live right now, even if you're watching this recorded, is actually going to find this before me and can help me out here. But I'm going to go under WebGL and light. So we would think probably in light.js, this maybe is where this issue might have happened. And I can actually, if I'm in that file, I could look at the history of just this file by, where do I, how come I don't see? By the way, I'm logged in as myself, so I have some ownership privileges over this repository. So you might actually, if you're following along and trying to do this too, this might look a little bit different to you, but everything you'll be able to see. So what I want to see is the history for this file. I don't know why I'm, let me just look at the, oh, history. Oh, there's a button right there that says history. So let's look at this. Format. So let's kind of like look along here. When was 0.5.16? When was that released? So let's look at, let's look at the date. Let's look under releases. I'm a little, and that was August 28th. So somewhere, right, because with 1.4 it's working. Let's just confirm that again. That's 1.4 and it's working. So and look, major WebGL updates. We can see that happened there. Let's go back here. So 15 days ago, November. So we can go all the way back. Here we go. Initial implementation of custom shaders. So sorry, this is so small. So we can now see there was a commit to this file on September 5th. There was a commit on September 11th, September 15th. Thank you, Kate Hollenbach and Lauren McCarthy, for all this amazing work. Zalastax. So let's see. Probably the print function is not related. Hopefully this is not related. My guess is there's got to be an issue inside one of these. So let's look at what these commits actually do. So I'm going to open these in new tabs so we can see. So we can see this is what, and this is a little difficult for you to look at because it's so sort of tiny on my screen. But we can see this changed. What changed here? Instead of this, yeah. So this is like a little bit of like, this to me looks like a minor change that's cleaning up the reference to how this is being used. This is removing shader and using this renderer current fill shader. So this could have something to do, ambient light count. So that's with the ambient light. Let's look and see if we can find directional light count. So this must be some issue here, right? Where is the, I kind of want to look at the point light. Do you think this could be for the point light? Let's see what else there is. Render, that's the same thing. Some material stuff changed. Point light. Ah, here we go. The point light changed. So this is the point light function changed. Point light. Let's look at that. So one thing we can do, once we've sort of found it, I might be able to go actually into the p5.js code itself and find point light, kind of hack with it a little bit. I need to find the actual function. Sorry, this is point light equals. Yeah, so this is me finding the actual function in the p5 library. And this is what changed this. So let's see, boy, this is, again, high degree of difficulty one. Now what's weird here is it doesn't look like, oh yeah, point light count. Let's look for that. That seems like that's going to be relevant. This might be, look at this, Amazingly, that's at like the, looking in the chat. Change the diff view to inline instead of side by side. Good point. So somebody in the chat is telling me that I can change the diff view to unified, I think. Yeah, thank you for that. That's going to help me a lot. So this has changed the way. Now the other thing, there were other commits, right? This is the one I'm just looking at here. Resolving conflicts. Let's look at that one. Well, that's the first one. Let's look at, so sorry, there were two, right? This is the initial, there's initial implementation and resolving conflicts. So let's also look at this initial implementation. Could it have broken in here? And I think actually now that I'm looking at this, so there is a moment where this point light count goes up. And then it should set it with a different point light. So whatever it did before, this solution does not work. So let's see if we can hack something together. First of all, let me at least just add console log this underscore renderer dot point light count. So let's see what happens now when I go to the sketch. Now one thing I need to do is I need to, oh boy. So one thing that's a little bit unfortunate is this is a massive text file. And there's no reason why I can't edit and play around with this, but I find that Atom tends to crash, which it looks like it's just done. So I'm going to switch to Visual Studio. Oh, I'm getting a good tip. This dot? I forgot. So hold on. I was so, yeah. Force close. So I'm gonna open this project up in Visual Studio because I need to use that. That's gonna be better, hopefully, in letting me play around with the actual P5 library. So one thing I want to do is make sure I'm using the P5 library, the current one that I'm editing now. And then I'm going to go into the libraries, and I'm going to go down, and I'm going to look for point light count. And this dot render. So I want to just sort of see. Whoops. I want to see what's happening in the sketch. So you can see 1, 2, 1, 2, 1, 2, 1, 2. So that's happening The count is going up every frame. Current fill shader set uniform, that point light count, this. So something is wrong. The point light location is being set. So am I getting a new point light location each time? Let's look at what these values are. So I am getting the point light location. So again, I don't know how any of this stuff works. This is like the underlying WebGL code. It takes the location, the color, and it kind of feeds it to these other renderer shadery things, and it should be making multiple ones. But for whatever reason, so what's going on? For whatever reason, when I make a point light, all that's happening, and it's getting the two different locations, but I'm just overwriting the last one. So something about cur fill shader being overwritten is the problem. I doubt we're going to be able to fix this in this video. This is what I said by high degree of difficulty. I probably should give up and just kind of point out that this isn't working and where I think the code problem is in the GitHub issue I'm about to post. But let's try a little bit more. Right? So current fill shader. Let's take a look at what this object is. Maybe I can learn something here. Ooh, undefined. So I'm going to say no loop to stop everything right now. And I'm just going to look at this object. So this is the object that it's doing stuff to. And actually, what would be really useful, I have an idea now, which is that what I'm going to do is I'm actually going to put, in my sketch, I'm going to put no loop here. And what I'm going to do in the library code that I'm messing around with is I am going to look at this at the end of each time, at the beginning and the end of each function time it's called. So I'm going to put this at the beginning. And I'm going to say console.log new light. So let's see where this gets us. Okay, so new light. Whoa, let me clear this. So we got a new light, and this is what the shader looks like, and this is what it looks like at the beginning, this is what it looks like at the end. And it seems like the important thing that it's messing around with is current set uniform. So what is that? So maybe that gets set in here. Is there a point light color, point light count, point light location? So look at this. Here's the point light location, here's the point light count, and here's the point light color. So now at the end of that function, oh, that's the end. It should have, let's go look at the end of the second one. If we look at the uniforms and we look at the point light count, why does it say 1? It should have gotten to 2. It should have gotten to 2. Right, and I'm getting some advice where what I normally would have done, you're right, is like just take the old function. But I think the reason why I'm not doing that in this case is because I think a really big part of the architecture changed. So this change is just is related to like the full architecture of how everything is working. So so it's not as simple, I think, of just replacing the function, which normally it would be. So this is strange that this size says 1. Because it didn't seem to really set it, right? It sets it as 2, and then it says set uniform to what that is, but it didn't get set to 2. Point light count, name, size, type, right? So that seems to not be taking. Did I forget the this dot again? Somebody keeps telling me that, but, right? So like, right? Hard code 2 in there and see. All right, interesting. Getting the suggestion to try hard coding 2 in here. Let's see. Wait, hold on. I'm going to hard code 2 in there. And let's look at the very last time. Uniforms, point light, count, 1. So I'm getting some interesting messages in the chat. Maybe the uniform changed name. Does set u point light count? Hold on a second here. U point light count, that's what it says there. Is this by definition, like u point light location? Let's look at u point light location. Size 8. So where does that value, where is the actual value though? Size, so size, sorry, size is like it's just one number. So it's actually, I think size, so the actual value is somewhere, these are just the uniforms. Sorry, this is just saying what the uniforms are. When I set it, it probably goes into the shader or the renderer. Ambient like, yeah, sorry. So this is really where I want to look. Current default light shader, is that where it's going to get set? Uniforms. Yeah, I think these are just the list of the uniforms. I am really lost here. I have no idea how any of this stuff works. I think probably I should just file my, I think I should just file this bug now and give up that this is going to be a new series. There was another object inside the uniform. Maybe in uPointLight. So Leonardo is saying there was another object inside the uniform. Scrolled past it. All right, thank you everybody. So let's go here. So hold on. Uniform. uPointLight count. Location. No. Name size. So what did I miss? What did I miss? Be more specific. Matthew Brown is saying I should really look at compare. All right, I'm going to try that too. Renderer. I passed it. Renderer. Okay. Everyone's got good suggestions here. Renderer. Renderer. Renderer, down at shaders, default light shader, uniforms. Is this where I need to look? Up. I don't know where. Right there, where? It passed it again. Okay. Attributes. Location 2, size. Point light count is 2. How come I don't see it? Count. It would be helpful if you were all more specific. Renderer, what's the next thing? What's after renderer? Scrolling up doesn't help me because you guys are 10 seconds or 20 seconds in the past, so you're at a different renderer point light. Oh, it's just in there as point light count. There we go. Thank you. Okay, point light count. I see it. So that's correct. But, so that value is correct, but are there actually, where does it keep track of both locations? Thank you, I see that now. Can I please give up now and go home? Yeah, we all found the point light count because it's on the screen. How many viewers have I lost now? But now I'm hard coding it. Yeah, I know. All right, let's Let's unhard code that. I suspect that that's working, like the value of the variable is correct. It's correct, point light count. The issue is, where does it keep track of, see there's the default, there's the current, it seems to me the issue might be around the fact that there's a current, this sort of like current light. So it's keeping track of the count correctly. Default light shader. So the question is there a current light shader? No. Current fill shader, current stroke shader. Default light shader. And let's look at the attributes. Position. Right? So this is just attributes, position. It should be passing an array of points through the uniform. You can log that array if you did not before. In the renderer one, you're probably right. So first of all, that's probably not even an issue here. That's a very good point, Leonard. Let me go back to some suggestions that people have had. I really just meant to file a bug, but so I'm going to just look at, one thing I'm going to look at is the compare. So there's a way I think I can form a URL that's going to just compare these two different releases. And under files changed, I can probably go to, let's look at the renderer. Which is the, hold on. Let's look under, boy, I really don't know what I'm doing, do I? Let's look under WebGL, renderer GL. Now let's look at this one. Now are we in immediate? I think we're in immediate, but let's look at just renderer GL. Yeah, this is where probably the light. So let's look at, so is there a way for me to compare between versions of a particular file? That's the question, right? So how do I compare a particular file? But I could just look for GL renderer, right? Renderer. What was it called? Renderer GL. Yeah, whoops. Large diffs are not rendered by default. Let's, whoa. Yeah, here, is this going to do it? Well, that's just the whole file. All right, wait, somebody had a sensible suggestion? You could add a breakpoint and debug the function. Oh, that's like, yeah, that's way too sensible. I've kind of done that. I just want to see, like, where does it actually, I want to trace where it actually sets that light. So in the renderer, wow, look at this crazy ambient light count. The renderer has a point light count, right? And it has a fill function. So let's go look. Yeah. Interesting. I'm just kind of like peeking through this. This is the thing. I have no idea how the WebGL system works at all. I really shouldn't be doing this. Yeah, the only thing in the renderer is the point light count. Let's see if that, setting a debug marker and letting it trace it for you. Console log, okay, hold on. No, see, I can see that it's working. This is what I've been console logging. Oh, I've been looking at the, oh, but I was looking at the fill shader. Ah. Let's just look at the renderer. Let's just look at the renderer. Thank you. Let's try that. Let's look at the renderer. Point light count 2. Default light shader. Yeah. Why am I missing this dot? Oh yeah, sorry. Thanks. It worked anyway. Yeah. I meant for this just to be a lesson in filing a good GitHub issue. Yeah, so here's the thing. These are all really excellent suggestions. For example, Turkey writes, copy only the correct rendering.js file from the new version to old and see if it fixed it. And then and only then do you know you're on the right track. The issue, I totally agree, and this is actually, I should have picked a different example. Like if there was kind of this small area, but I'm pretty sure that between 0.5.14 and 0.5.16, like all of WebGL was rewritten to do to work in an entirely different way. So there really isn't one thing that changed. This is a pretty poor example. It's like everything changed. So at this point, I just need to know how the current system works and find out why I can keep track of multiple. So it didn't really break. It's just like the whole thing got rewritten and some stuff stopped working. So that's really, I think, more of the issue with this particular. And so I think what I'm going to do now, and this probably can't be salvaged. I love the idea of doing this. Is I think I'm going to just file a GitHub issue. So let's look at. All right. So if this is going to be salvaged into a tutorial video, at some point a long time ago, at Mathieu's discretion, I'm going to stop and say, well, okay, let me find a window to be on. Okay, that was a weird edit point, if this video ever exists, but I went down many different rabbit holes to try to find the bug, and you might have seen some of that happening in what you watched up until now, but this was pretty much a case where my skill level, I cannot fix this bug. There's a couple of reasons. One, I don't have all day here, I gotta go have some dinner. Two is, I don't really know how the WebGL system works. I wasn't one of the ones who designed it, and I won't be able to investigate that fully right now. And three, like this is a case where it wasn't like a small bit of code changed that broke that I could look at reverting. Over the summer, between versions 0.5.14 and 0.5.16, a lot of WebGL was kind of rewritten in structurally, so much changed, and I think it's less a case of like this thing broke and more of WebGL was rewritten in a new way and some things aren't working anymore. So the next step could be filing a GitHub issue that's as helpful as possible. So let's do that together here in this video. So I'm going to go back to the p5.js repository, and I'm going to go to issues. And so first thing you should always do is I should look to see if there's already an issue. So I'm going to search for point light. Point light not working. That's October 9th. That's interesting. Issue with positioning point lights. So this could actually be our issue. Let's take a look. So this seems to be describing something different. And look, we should aspire to have such a well-written issue. I guess point light should use real world rather than a normalized direction like directional light. So this seems to be something different. This seems to be an issue with, and also this is using a previous version of P5. So I'm going to not worry about that. So this I don't think is our issue, although it might be related. And positioning point lights. So this, I think, is also a similar issue. And so this is probably worth referencing these two issues. And then I just want to look at, so let me save this here. Let me save these two issues. And let me look, what else could I look for? Lights? Yeah, issues. So I don't think there's anything else related to the lights, to this issue. So I think we can file an issue. So I'm going to write a new issue. Now, what I'm going to say, only one point light or directional light works. So what's a good title for this issue? What's a good title for this issue? Let's see. I'm trying to think of a good one. Subsequent calls to point light overwrite previous point lights. Multiple point lights or directional lights not working. I don't know. Maybe that's, I don't love this title. Maybe somebody can think of something better. Now this is helpful. I'm going to, this can be, so this has like a helpful guide. So what I'm going to do is, instead of this, I'm going to say, I'm going to leave some of this in here. I'm going to say, found a bug. And the most appropriate area is WebGL. And which platform? So this is using desktop. And p5.js version, we are using 0.5.16. Web browser is Chrome. And I'm going to say about Chrome. And I'm going to put this in there. Be really diligent about this. And I'm going to say operating system, Mac OS X, and my operating system is 10.11.6. 10.11.6. And now I'm going to take out these comments, and now I want to describe how do I reproduce this bug. So the following code, in the following simple example, which positions 2 point lights, one on the left, one on the right. Only the last point light is illuminated, is active, is seen, is, I selected mobile, sorry, thank you. The platform is wrong. I got it. Is one on the left, one on the right, only that is activated, is active. So now I want to add some code. So one thing you can do is when you want to add a block of code, you add it in between these backticks, and you can actually say the language. And I can now go to the sketch, which is my code here. And I can get rid of this and just do this. So I'm going to add this here. So now I'm going to put this here. The other thing I could do to be really kind of crazy is I could add some screenshots. So I'm going to say this is with the red light second. So now I'm going to go to, I'm overdoing it just for effect here, which, you know, some of this may be unnecessary. So, I'm going to take a little screenshot of this. And then I'm going to say, and now I'm going to do the blue light second. And I'm going to do this. And I'm going to say, back to my issue. Following, with the red light second, i.e., and I'm going to take these two here. And then I'm going to upload that image, that screenshot. which should be on the desktop of this one, and that's the red light second, with the blue light second, and I'm going to take this screenshot, and I'm going to put the code in there. This bug appeared somewhere between 0.5.14 and 0.5.16. Using 0.5.14, both lights are active. So now I'm going to go back to my code, and I'm going to switch to 0.5.14, which I think that's what I'm doing here. I'm going to run the sketch again. I have too many things open, and I'm going to screenshot this, and I'm going to add that to this issue. I'm going to add that in here. Whoops. I'm going to add that in here. Oh, I broke my computer. Stop. Why is that there? Go away. Finder. Ah! Everything is falling apart. I'm going to force relaunch my Finder, because I don't know why that just did that. And then I'm going to grab this one and put this here. And then I'm also going to write. I'm also going to write the same bug exists for directional light. This may be related to, and then so I'm writing here, this may be related to, and so remember I had these issues, 2251. So I want to reference those other issues by their number. 2251, that's an issue that I think might be related, and what's the other one? 1622. Then I'm going to say, this issue was filed by the viewers of the Coding Train Live. Okay, so now the next thing I can do is I can check my work. So I can go over here to preview, and we can see here, oops. So I've got some weird mistakes here, which is I got like some spaces here. So I found a bug, WebGL, p5.js version, web browser operating system. In the following simple example, which positions 2 point lights, one on the left and one on the right, only the last point light is active. I don't like the way that sounds. Only the second call to point light, the second call to point light overrides the first rather than adding a new light. That makes more sense, I think. So the second call to point light overrides the first rather than adding a new light. So here's the code with the red light second. Oh, these are huge, these images. That's fine though, I guess. And then with the blue second light, this bug appeared using 0.5. Both lights are active. The same bug exists for directional light, and this may be related to this. Okay. Calling all viewers. I think this issue is done. Does anybody have any suggestions, anything that I missed or anything that would be helpful here? Adding a point light overwrites the previous one. Yeah. The second call to point light, and let's call that, let's make this a function. And you can use a single backtick overwrites the first rather than adding a new light. Overrides, overwrites. So should I say, the question is, do we like this title? Anybody have any better suggestions for this title? Yeah, I suppose the convention could be to say this, multiple point lights. I don't know. I'm going to leave it lowercase. So Austin is saying that I should have checked if the issue was closed and reported in a previous version too. I should. I'm too tired now. So please, if somebody finds something else that's relevant that it was open and closed, please add that as a comment to this issue. Only the final light source is rendered. Okay, I like that. Only final light source, point light, directional light, is rendered. Do we like this better? I think this might be better. Let's use the camel case for these since they're the function names. Someone's saying there's a 2257 issue. Is that what I said already? Oh, there's also 2257? Okay. Let's look at that issue. 2257. Fixed directional light and point light. Oh. Oh. Ah. So maybe this is before. Oh, right, because it could have been. You make a really good point. So one thing I didn't do. Oh, boy. So I really botched this. Austin's saying, I should check if it's been closed already, because it could have been fixed and closed, but not in the new release, 0.5.17. Oh, I really should have said that earlier. See, I'm just figuring all this stuff out too. So let's be a little bit. Let's actually look for this. So I'm going to go back to looking for lights, and I'm going to look under closed. So it doesn't look like any of these. Let's look at point light. So, oops. So I'm not finding anything. This is closed November 7th, November 2nd. So these seem to be different, right? These are some things that happened recently. What was the date of 0.5.16? This was on October 11th. Oh, look at this. So 2257. Wouldn't it be funny if this has been fixed already after all of this? October 11th. Reviewed, commented. Please see the new pull request here. So this fixed directional light and point light. Has this been fixed? This was merged on November 2nd. Oh, I love the lessons we learned in programming. But is it just the documentation? Let's look. It looks like it's just the documentation. Right? Everybody look at this with me. It's just the we could be certain about this. It's still broken on master. Okay. Right. So Henninger is saying I should try the latest revision from master to see if the bug has been fixed. I should, but then I'd have to get the whole thing and build it, and I don't know. Now I really it's after 6 o'clock now. I've been doing this for 2 hours. So thankfully, okay. Another thing that I should have tried is to actually check, because there have been some things that okay. One thing that I should mention that I should have also done a search for is that there have been 382 commits since October 11th, and 0.5.16 is from October 11th. So one of these could have actually fixed it, and I'm not going to see that fix. So I should search through also the closed issues. I couldn't find anything, and a very kind viewer has actually checked that the current version of P5, even from GitHub that's newer than 0.5.16, isn't working. So I think this issue is ready to be filed. Now, I should do a follow-up video, somebody remind me of this, to show you how do you really check that. How do you build and use p5.js from the GitHub repository? So how do you have the most recent version that includes fixes following the most recent release. That would be worth looking at some point in this new series I have about how to work with open source projects on GitHub, hopefully better than I can do. Because I'm apparently not very good at this, but I'm trying my best. So let's go back to that issue. And everyone's telling me to close all my tabs. I definitely should. So our final title is, only the final light source, point light, directional light, is rendered. And this is all the code. These are the different screenshots. I think this is ready to go. I don't know about the title. I'm still not so sure about the title. But this is going to have to be, yeah, there could be nightly builds. Oh, this is too much going. We'll talk about this up in another video. OK, Mathieu, if you can salvage this, you are a genius. I'm going to submit this issue. This is very exciting. Oh, now I don't think you have the permissions to do this, but because I am an owner of this repository, I can actually tag it with WebGL. So I'm going to do that. I'm going to do submit. Yay! Woo, there's our issue. Yay! All right, thank you, everybody. Good night. Good night. Good night. Thank you. Thank you. Thank you very much. Thank you very much. Thank you. Thank you. Thank you. That went so well, just as I had imagined. Huh. Wasn't it broken in 0.5.13? Oh. Oh, I forgot that pull request. Oh, shoot. No, but that was just the docs. So I think that docs isn't worth mentioning because it's just the pull request. But do I really have to check this now? Let's go back to here. No, it's working in 5.1.3, 5.1.2. So it worked everywhere time before the summer. OK. OK, so now we're done with that issue. What was the other issue? Custom shaves, error of camera. All right. Let's do another. Come on. OK, no, I'm going. So this is another GitHub issue. Anybody who watched this video and feels so inclined and feels like they feel empowered and they feel like this is no big deal, I can file an issue. I think an issue should be filed that you get a console error in your sketch breaks if the camera and the center are the same. Maybe it should just give you a friendly error. Maybe the error is fine, actually. Think about that. Is that a bug or is that the appropriate behavior? I don't know. All right. I really should read some random numbers, right? I mean, we've got to do that. I'll be back tomorrow, but I really should do that. Now, somebody last time told me where I last left off. What did I do this for, like, so many hours? It's ridiculous. Where did I last leave off? I remember I read the foreword. There's no way I read the acknowledgments. There's no way I read this whole introduction. Oh my God. I don't know if I can bear to do this. I guess no, I know, but see, I made this commitment to, instead of just when I read random numbers on the coding train, because that's what I like to do, instead of just flipping to a random set of random numbers and reading them, I made this commitment to actually kind of like keep track of where I last was and read all of them all the way through. So the problem is that I thought, oh, I should also read the introduction, which is actually like really long and has a whole bunch of tables of numbers in it. So maybe I should just start here, come back to the introduction. Right? And I should definitely, I'm pretty sure that I think this repealing of net neutrality is a pretty bad idea. It's a nuanced issue. I obviously am mostly, from everything I've read and learned about, I am in favor of net neutrality. So here's my random number protest. Good night, everybody. 10,097, 32,533, 76,520, 13,586, 34,673, 54,876, 80,959, 9,117, 39,292, 74,945, 66,065. No, I lost my page. Wow, it's a really long lullaby. Wait, no, that's not, where was I? 64. All right, everybody. Right. All right. You know what I'm going to do? I'm going to make a computer program that can read this for me. Just like let it stream forever. All right. Thank you, everybody. Good night. I appreciate your time in watching this YouTube channel. I can't believe it is 6:15 now. I've completely lost my darn mind. I'm looking at my phone. I will see you all. Apparently, I'm coming back tomorrow morning, which now seems completely insane to me. But I will be back here tomorrow in the morning, probably around 10:30. I really have absolutely I have to stop by 1 p.m. tomorrow. So, and I would love to get to the Word2Vec stuff. I would like to do these things. Oh, you're not seeing this right now. I would love to do this stuff as well. So we'll see. Really short protest, yes. Okay. Thank you, everyone, and I'll see you soon. Any last questions? I don't know what I'm going to do tomorrow. I would love to keep going with this WebGL stuff, redo anything from today that's too much of a disaster, and maybe look at custom shapes, texture, and create graphics. We'll see. All right. Word2Vec. Yeah, I know. That's on my list. Next week, I don't know. And maybe iTerm. Yes, maybe iTerm. Okay. I need a good way of like ending. Oh, yeah. Okay. Wait, hold on. I think what I should do, I've got an idea. This is a really important thing that I'm doing right now. Whoops. Oh, buffering black is not doing. And then unlock it. Move myself here. Everyone do what you will with this. Hold on. I've got a better idea. I'll give you guys something to work with. Filters. Yes. Oops. And, whoops, there we go. Oh, hold on. Hold on. I really lost my mind. Okay, now, yeah, Sean says, oh no, Dan, you're asking me to turn to a meme. Yeah, hello. What do you think I'm doing this for? And I'm open to suggestions. Any requests? I'll take some requests before I go. Please do a stream with Python. No, don't you see I'm just here doing ridiculous stuff with my green screen loading animation? I mean, there's always this too. I mean, here's the thing. I could also Okay, I think I gave you enough material. You know, more kittens. Oh, kittens. You put the kittens in. Yeah. This is very dangerous. Yes. Okay. I'd like to live on the edge. Okay, I think I'm going to go. And I look forward to waking up in the morning tomorrow and seeing all of your creations. Okay. Background music. All right. I'm going to go. I'm going to go. I'm going to go. Do the stairs. Oh, the stairs is a good one. Okay, okay. That was pretty terrible. Try this way. Okay. Yes, I do. Okay, okay. The problem is I'm like looking at myself while I'm doing this, so I'm not looking at the camera. So. All right, the Egyptian one was pretty good, right? Okay, I've done enough now. I'm really turning this off. Okay. Well, that's my exercise for the day. What's my Fitbit say? I got, my heart rate's up to 115, and I've got 9,274 steps. All right, I'm going to now hit the, I'm officially now going to hit the stop streaming button. Just kidding. Okay. Goodbye, everybody. I'm happy to do more of these tomorrow. No worries. Okay, goodbye, everybody. Good night. I'm going to hit stop streaming.